Welcome, agents, to the Bizarre Bureau. What if I told you the ancient Romans built structures that could heal themselves? For 2,000 years, monuments like the Pantheon and the Colosseum have stood against earthquakes, waves, and the relentless march of time, baffling modern engineers. How did a civilization without our advanced technology create a material so durable it puts modern concrete to shame? For centuries, the recipe was lost, a ghost of engineering genius. But recently, a team of scientists cracked the code, and the answer is more bizarre and brilliant than anyone imagined. It wasn't a mistake or a happy accident. It was pure, calculated genius. For the longest time, the prevailing theory was all about volcanic ash. The Romans, particularly around the Bay of Naples, had access to a special kind of ash called pozzolana. When they mixed this with lime and water, it created a powerful chemical reaction, forming a uniquely stable and water-resistant mortar. This pozzolanic reaction was considered the secret ingredient. It explained why Roman sea walls and piers, constantly battered by the Mediterranean, were still standing. The salt water, instead of eroding the concrete, actually triggered chemical reactions that made it stronger over time. This was a fantastic discovery, but it wasn't the whole story. It explained the strength, but it didn't explain the longevity, the almost magical self-healing. Scientists examining ancient Roman concrete kept noticing these tiny, millimeter-sized white chunks scattered throughout the mixture. For decades, these were dismissed as evidence of poor mixing. The assumption was that the Romans weren't thorough enough, leaving little clumps of unmixed lime in their concrete. It seemed like a flaw, a sign of primitive technique. But that assumption didn't sit right with some researchers. Could a civilization that engineered such monumental and lasting structures really be that sloppy? What if these little white chunks, these lime clasts, weren't a mistake at all? What if they were the key? This is where the new breakthrough comes in, led by a team from MIT and other institutions. They decided to look at these lime clasts not as a flaw, but as an intentional feature. Their hypothesis was radical. What if the Romans weren't using the standard form of lime, known as slaked lime, but were instead using quicklime? Let's break that down. To make concrete, you start with limestone. You heat it at very high temperatures to create something called quicklime. The standard practice, both then and now, is to then mix that quicklime with water in a process called slaking. This creates a stable, paste-like putty called slaked lime. But the MIT team proposed that the Romans might have been skipping that step or doing it differently. They suggested the Romans were hot mixing, adding quicklime directly to the pozzolana and sand mixture before adding water. This would be an incredibly intense process. When quicklime reacts with water, it generates a massive amount of heat, with temperatures soaring above 200 degrees Celsius. This exothermic reaction would do two things. First, it would create chemical compounds that wouldn't form at lower temperatures, making the entire concrete mixture stronger and more durable. And second, it explains those mysterious lime clasts. The intense heat would cause pockets of lime to form into these characteristic brittle nanoparticle structures. These weren't signs of sloppy work. They were the deliberate fingerprints of a high-temperature, hot mixing technique. So, we have these brittle lime clasts embedded throughout the concrete. How does that make it self-healing? Imagine a tiny crack forming in a Roman wall due to a small earthquake or ground settlement. As the crack spreads, it eventually reaches one of these little white chunks of lime. Now, here's the magic. When rainwater or even moisture from the air seeps into that crack and touches the lime clast, a chemical reaction begins. The lime dissolves and then recrystallizes, filling the crack. It's like the concrete has its own internal repair system, a network of tiny first aid kits ready to deploy the moment damage occurs. The crack is effectively sealed from the inside, preventing it from growing larger and protecting the structure's integrity. It's a natural automatic repair process, happening silently for millennia. To test this theory, the scientists didn't just speculate. They did what any good investigator would do. They recreated the recipe. They made 2 batches of concrete. One using the modern cold method with slaked lime, and another using the ancient hot mixing method with quicklime. They then deliberately cracked both samples and ran water through them. The results were astounding. Within 2 weeks, the cracks in the Roman-style hot mixed concrete had completely healed, and water could no longer flow through. The modern concrete sample, however, remained cracked. The experiment proved it. The lime clasts were the key to self-healing. The Romans hadn't been sloppy. They had been masters of chemistry, designing a smart material 2,000 years ahead of its time. This discovery is more than just a fascinating piece of history. It has profound implications for our future. Modern concrete production is a huge contributor to global carbon emissions, accounting for about 8% of the world's total. That's because manufacturing Portland cement, the key ingredient in modern concrete, requires firing limestone at incredibly high temperatures, around 1,450 degrees Celsius. The Roman hot mixing method, while still hot, operates at a significantly lower temperature, which could mean a massive reduction in energy consumption and carbon emissions if we were to adopt it. Furthermore, our modern infrastructure is crumbling. We spend billions of dollars every year repairing bridges, roads, and buildings made from concrete that has a lifespan of only 50 to 100 years. Imagine if we could build structures that, like their Roman counterparts, could last for centuries, healing their own cracks and reducing the need for constant, costly repairs. Adopting a form of self-healing concrete inspired by the Romans could revolutionize the construction industry, leading to more sustainable, durable, and cost-effective infrastructure for generations to come. We could be on the verge of a new age of construction, all by looking back and finally understanding the lost genius of the past. The story of Roman concrete is a powerful reminder that sometimes the most advanced solutions are hidden in ancient wisdom. It is a tale of how what was once dismissed as a flaw turned out to be the masterstroke of an engineering empire. The Romans weren't just building for their time. They were building for eternity. And by finally cracking their code, we might just learn how to do the same. This isn't just about admiring the past. It's about building a better future. Thanks for joining us at the Bizarre Bureau. If you enjoyed uncovering this ancient secret with us, don't forget to like this video and subscribe to the channel for more investigations into the world's most fascinating mysteries. Hit that notification bell so you never miss a case. Until next time, stay curious.